review quadratic expressions and quadratic equations. Number 10 is a quadratic equation because you have a squared on the variable, and that's the highest exponent. Let's simplify the 10 squared first. And for this one, this is a simple quadratic equation because you don't have what's called a linear term. In other words, a term where the exponent is 1 on the variable. So we can treat this like a linear equation with the goal of getting the variable by itself on one side. So I will add 44 to that end, and I get that y squared equals 144. So what this is saying is, what number squared is 144? The obvious answer is 12, but also negative 12 can work. Negative 12 times itself is also positive 144. Another way of thinking of the solution here, or the solution step, is to square root both sides, just keeping in mind a plus or minus on the other side. So we get that y equals positive or negative 12. There's going to be quadratic equations that are more difficult than that, or more complex than that. Ones that involve linear term, for example. So before we solve those, let's do some factoring review. Number 11 is an example of a simple quadratic trinomial. It's quadratic because the highest exponent on a variable is 2, and it's trinomial because there are 3 distinct terms. To factor these, what you can do is look at the last term, the constant term, and figure out 2 numbers that multiply to be that add up to the middle term. Now in this video I won't cover the theory as to why that is. You can ask me if you care. But we'll just do, as I said, the solution. I will use P and S to indicate product and sum. The product here corresponds to the last term, negative 18. When we do more complex examples, it will be the product of the leading coefficient and the constant term. But for now, it's just negative 18 in this case. The sum is the middle coefficient, negative 7. So it's a numbers game. Find 2 numbers that multiply to negative 18 and add to negative 7. So think about factors of negative 18. 6 and negative 3, for example, but 6 and negative 3 add up to be positive 3. So that's not going to work. 9 and 2, well, one's got to be negative. Positive 9, negative 2, that doesn't work because that would be positive 7. So let's do the opposite of that, negative 9 and positive 2. That's the hardest part. Now you can just go right to the solution. Quadratic trinomials always factor to 2 binomials. And we take the variable, write it as the first term in both sets. Then we use these 2 numbers that we found to fill in the rest. So minus 9 and positive 2. And you can multiply those 2 using FOIL, or the distributive property, and you would find out that when you did so, you would get this. Number 12 is similar. Find 2 numbers that multiply to be 8 and add to negative 9. Pretty easy. Negative 8 and negative 1. Notice that both of them have to be negative because this is a positive product, but the sum is negative. Then you just go right to the parentheses to get m minus 8 and m minus 1. So it's pretty easy.